This video is on testing of hypothesis. We know a hypothesis is a statement about a population. It always talks about the parameters of the population. Okay, and the null hypothesis is framed with the null attitude, and the alternative hypothesis, which is denoted as H1, may be two-sided or one-sided. Okay. When the alternative is two-sided, you have critical region in both the tails. When the alternative is right-sided, you have critical region only in one side. When the alternative is left-sided, you have critical region here. The size of this critical region is alpha. In two-sided, this is alpha by 2 and this is alpha by 2, and on the whole the size of the critical region is alpha. Okay. Now, the hypothesis testing problem is a two-action decision problem, and since you are doing it based on sample, there is a possibility of committing two types of errors. And the errors are type 1 error, which means your sample will ask you to reject H0 when H0 is actually true. And type 2 error, your sample will ask you to accept H0 when H0 is actually false. Right? These two errors tail of each other. That is, you cannot completely do away with both the type of errors. If type 1 error decreases, type 2 error increases. So they tail off each other. Okay. Now, probability of type 1 error is probability of rejecting H0 when H0 is true is denoted as alpha. Probability of type 2 error, which is the probability of accepting H0 when H0 is false, that is probability of accepting H0 when H1 is true, is denoted as beta. So 1 minus beta will be 1 minus probability of accepting H0 when H1 is true. That is probability of reject H0 when H1 is true. Right? 1 minus acceptance region is the rejection region. Okay? Reject H0 when H1 is true. So reject H0 when H0 is false. Actually, what is the meaning? It is reject H0 when H1 is true means H0 is false. So it is the correct decision. So the probability of taking correct decision is denoted as 1 minus beta, and hence it is called power of the test. 1 minus beta is called power of the test. Okay, fine. See, the test statistic, you know, t minus expectation of t divided by standard error of t is the test statistic, and that the distribution of this test statistic, you assume that this is the curve for the distribution of the test statistic, and this is your rejection region. So the remaining area is 1 minus alpha, which is called acceptance region. In confidence interval, you call this region as confidence region. Okay. So between these two ordinates, there is 1 minus alpha probability that the parameter will lie. You find the values of confidence interval in such a way that your parameter, the probability that your parameter lies within this interval is 1 minus alpha. For specific derivations of the confidence intervals, go through the videos for confidence intervals, right? For each parameter, confidence intervals have been derived. Go through the videos. Now the value, see this value of the ordinate which divides the acceptance region and rejection region. This value is called critical region. So what is critical region? Critical region is the value of critical value. Critical value is the value of the test statistic which divides the critical region and the acceptance region. Okay, which divides the critical region. What is the other name of critical region? Rejection region, right? So critical region, acceptance region and rejection region are separated by means of a value which is called critical value. What is critical region? It is the region of rejecting H naught. Critical region is the region where H naught is rejected, and acceptance region is the region where H naught is accepted. Okay, right. And now let us try to understand one other term, significant difference. To understand this term significant difference, you should understand the meaning for sampling error and non-sampling error. Sampling error is the error occurs due to sampling techniques, due to the application of sampling techniques. The error in any investigation may occur due to measurement bias, measurement error, enumerator's bias, right? So these errors are non-sampling errors. The errors which are due to the application of sampling techniques are called sampling error, and the errors which are due to some other reason, typing error, printing error, right? These are all the causes for non-sampling error. Okay. Now, if the error, what is error actually? Error is the difference between the statistic value and the parameter, which you cannot avoid. Okay. This error, if it is due to sampling error, it is not, the difference is not significant. Okay. If error is due to sampling error, it is not significant. This is the idea. If it is due to some other reason, then it is significant. So when you say significant difference, you should understand that the error, the deviation which occurs between the statistic and the parameter is because of non-sampling error. Okay, right. So with this idea, let us discuss some of the basic questions related to these terminologies. Okay, and then let us discuss something about the tests, specific tests. In which of the following situation will you say that the test is two-sided? I told you, when you have critical region on both the sides, the test is two-sided. This will be the case when the alternative is two-sided. See here, the alternative hypothesis is one-sided, right-sided. Here it is left-sided. Here it is not equal to means both the sides. Okay. And here again it is both the side, two-sided. So C and D are the right options. Let us change this option as less than. Okay, right. So the alternative is two-sided in the third case. Rejecting H naught when H naught is true is called type 1 error. Rejecting H naught when H naught is true is called type 1 error. Accepting H naught when H naught is false based on sample. Why this error occurs? You're trying to take a decision based on samples. Actually H naught is false, but your sample is misguiding you. It is telling you that it is asking you to accept H naught when H naught is false. So this is one error which is called a type 2 error. By significant difference, right? By significant difference, mukkyathvam vaayintha difference, we mean that the difference is due to non-sampling error. Significant difference occurs due to non-sampling error. If the difference is due to sampling error alone, it is not a significant difference, right? It is not, it is a significant difference. No, that is not correct. This is not correct. If the difference is due to sampling error alone, it is not significant. Okay? Your test statistic and its distribution will take care of this error. That is the idea. Okay? The probability of type 1 error is denoted as alpha, which is called a level of significance. The confidence level is 1 minus alpha. The probability of type 2 error is beta. Okay, the probability of type 2 error is beta. The probability of type 1 error is alpha. The power of a test is accepting H0 when H0 is true. Is it correct? See, I have explained here. The power of the test is rejecting H0 when H0 is false. Right? 1 minus beta is 1 minus probability of accepting H0 when H1 is true. 1 minus acceptance region is rejection region. Okay? So, rejecting H0 when H0 is false is the power of the test. So, rejecting H0 when H0 is false. Actually, this decision is also correct. Right? This is also a correct decision. But 1 minus beta is this. Okay? Rejecting H0 when H0 is false. Power of a test is the probability of taking correct decision. But you may get confused that this is also a correct decision. But this is not the answer. Rejecting H0 when H0 is false is the answer. The power of the test is denoted as 1 minus beta. The level of significance, probability of type 1 error is level of significance. Probability of rejecting H0 when H0 is true. This is actually type 1 error. So, probability of type 1 error is your level of significance. Which of the following is true about the critical value? It is the value of the statistic which divides the rejection region and acceptance region. It is the value of the statistic which divides the critical region and rejection region. This is not correct because the other name of critical region is rejection region. Okay. So, the statistic which divides the rejection region and acceptance region is called critical value. So, since you have critical region and rejection region, they are the same. So, this is not the correct option. It is the value of the probability which divides the rejection region and acceptance region. No, this is not correct because it is the value of the test statistic. So, option A is correct. Okay, critical value. See, for the test statistic, you are plotting the probabilities and the value of t for which, the value of the test statistic, it may be Z or small t or f, for which the value of t which divides the critical region and acceptance region is called critical value. Right? Okay. Which of the following is the sampling error? Enumerator's bias. The person who is collecting the data is committing some error. It is non-sampling error. Defective scale of measurement. Defective scale of measurement, that is measurement error, non-sampling error. Wrong calculation is also non-sampling error. Wrong selection of sampling technique is the sampling error. Which of the following is true about an estimator and an estimate? Estimate is the value of the estimator. Yes, that is correct. Estimator is a function of all observations of a population. No, the function of all observations of a population is a parameter. Okay. An estimator is always less than a parameter. You cannot make any such statements. Right? None of the above. No, estimate is the value of the estimator is the right answer. The probability that a parameter lies within the confidence interval is, this question is similar to one previous question. The confidence level is 1 minus alpha, this, okay. So, the probability that the parameter lies within the confidence interval is 1 minus alpha. While finding the confidence interval for population mean, the area at the tails when you are finding the confidence interval for population mean, right, you will have the rejection region at both the tails. The total area of the rejection region is alpha. Here it is alpha by 2. Here it is alpha by 2. You are dividing it by 2. So the area of the rejection region at tails is what? Alpha by 2. Right? So for this, to get more clarification, go through the videos on confidence intervals. Right? The derivations made separately for the parameters. If you have any doubt in understanding, go through the video. Okay? Rest of the questions let us discuss in the next video.